Hello everyone, I'm Lin Zhang from National Institute of Informatics. I will share our recent published work, the PartialSpoof database and countermeasures for the detection of short fake speech segments embedded in an utterance. In short, it is a story about PartialSpoof, and you can find our published work from this code. As defined on standard ISO IEC, the biometric technologies are often used as a component in security systems. Our human can use our own object to unlock those security systems and then get further services. However, those biometric technologies are also vulnerable to presentation attack entrapment. That means the attacker can simulate your voice, fingerprint, or others to unlock those security systems. Thus, presentation attack detection or countermeasure is needed. For presentation attacks entrapment, it can be divided into three different parts by how they generated. The artificial one, or generated by human or other nature. The artificial one has two different types, complete fake or partial spoof, and we focus on partial spoof in the speech field. So how to defend against the partial spoof attacks? We propose here might be two different tasks, whether and when. Whether the input utterance is spoofed or bona fide. When do spoofs happen? We have two previous works on that, but here are some limitations. For example, the score in segment level still has some limitation which can only present a segment with a fixed length. Thus, in this paper, we proposed a more flexible multi-resolution countermeasure to explore the segment-level detection in different resolution. In summary, our new paper, including three parts, we proposed the multi-resolution countermeasure and have done several experiments on that. Let me first give a quick recap on our previous work on partial spoof. When we explore this topic, there is no open source database, so we built one database named PartialSpoof. And here is the partially spoofed audio in our database. In one utterance, here might including both bona fide and spoof. And this database is based on ASVspoof 2019 LA database. In the right part is the information for our database. And you can see here can including several different TTS or voice conversion methods in one utterance. You can scan those codes for more information. Then for the first question, whether the input utterance is spoofed. Following the conventional countermeasure, we can achieve this goal. Given an input utterance, the countermeasure can derive an utterance-level score to detect whether the input utterance is spoofed or bona fide. The output is an utterance-level score, and the countermeasure usually consists of two parts, front end and back end. For the second question, when do spoofs happen? We also need a countermeasure, but the output should be a sequence of segment-level scores. That means one score per segment. For the second question, when do spoofs happen? We also need a countermeasure, but the output should be a sequence of segment-level scores. That means one score per segment. We can achieve those two different questions independently by using those different utterance-level countermeasure or the segment-level countermeasure. We can also achieve those two scores simultaneously based on the multitask learning as shown here. However, as I introduced previously, there are still limitations on that. The segment level score can only predict the score for segment with limited length, which is dependent on the encoder structure. Thus, we proposed this new multi-resolution countermeasure, which including different branches for several different resolutions. It can be from frame level, for example 20 milliseconds, until the utterance level. And when we train the model, we can use only one branch for single resolution, or all the several different branches for different multiple resolutions. Meanwhile, we also introduced advanced architecture here, the Wave2, VAC2, and GMLP. Here is the result, and you can see that our new proposed countermeasures can achieve better performance, and it can detect spoof at different resolutions. Specifically, the utterance-level spoof detection can benefit from the use of more fine-grained information based on the multi-resolution structure. But can the countermeasures trained on partially spoof detect fully spoofed utterance? So we have these cross-scenario experiments as shown here. Here is the results. We can use either LA that fully spoof or PS that partial spoof to train the model, and then evaluate the countermeasure in different databases. And you can see here, using partial spoof training data is beneficial. The countermeasure still keeps stable in both fully spoof and partial spoof scenarios. In summary, our work focuses on a new spoof scenario, partial spoof, which includes two different tasks: whether the input utterance is spoofed and when do spoofs happen. And we also introduced the different solutions: single task, multitask, and multi-resolution countermeasure. We got several conclusions on that. New proposed countermeasure can detect spoof at different resolutions and can improve the performance. And using partial spoof training data is beneficial when evaluated on both fully and partial spoof. Because of the time limitation, please go to our paper for more details. We also have some analysis on the gap between development set and the evaluation set. Please find more details from this QR code, and you can also contact me if you are interested. Thank you.